I 8 minutes overview. It's a crime. 8 minutes. Come on, machine. Need to estimate overhead line parameters. How can we not know how to estimate an overhead line parameters? Oh, 9 centimeters of snow that flight. 9 centimeters of snow.
Yesterday celebrating 81 is a night
In
Ah,
linear
they are decorating some buildings and using the holy lights.
Haunted festival.
Yeah.
So it's a festival. Okay, this is not needed. This is no. Zero viewers. Zero, zero. Okay, what I'm thinking about? I'm thinking about line with lighting protected cable. One tower, two tower, protected cable. In Latvian, it's tross. I will use T. It's Latvian designation. Small insulators. Mm, 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 mm. mistake. And 1, 2, and 3 phase wires. Here, grounded. Tower is grounded. Yeah, nice. What we got here? Okay, correct. Wait. It's a mutual inductance, magnetic coupling between phase A and protected cable. And one more.
Professor, this is the protection cable, right? In the top,
Yeah.
this one.
Yeah.
This one.
Yeah, this one. You have 2 parallel lines, and this one upper is protected cable.
Good day. Good day. Okay. What is the purpose of the cable, Professor?
The purpose of this cable, in case of lighting, it will catch the lighting discharge protecting line.
Okay.
If, okay, it's a cloud,
So interfere.
and it will protect the line from.
Okay. I understand.
But what I'm talking about, we have 3 magnetic coupling.
Okay.
Distance via cable, this distance are not equal.
Yes.
Yeah.
Layer 1, layer 2.
1, 2, 3.
Three.
Okay, it depends on line design. There are line with horizontal phase displacement. That means what you have one layer and anyway 3 different distance.
Yes.
Or in vertical or in delta shape. Actually, if we speak on land usage, delta are most preferable. Horizontal spacing use much land, but for higher voltage, it's better because tower is cheaper. For lower voltage, delta is more preferable. For higher voltage, horizontal placement is more preferable. What I'm doing today.
Professor, actually, that cable, another name is ground wire, right?
It's protective. It's not
Ground.
ground wire or protective wire is bit different. Grounding is used to protect humans, animals, and so on from electric shock.
Okay.
It's a grounding. It's a protective measure. This wire is grounded, but it's a lighting protection. Give me 1 second. See where the question is. Since these 3 couplings, these mutual inductance, are not equal because distances are not equal, sum of the induced voltage will be not 0, and you always will see if, let's say, we have this is C current flows in this direction, induced will be directed this way, and you will see a circulating current in the. It's in the loop. Tower, protective wire, ground, next tower. It brings losses. That's why for lines somewhere in 60s, common design model was which interrupted this wire. This means on the draw something like this. So I have one tower, next tower, insulator, next again insulating dish, interrupted, but here always spark gap. In case of lighting, this spark gap opens and current flows to the ground. Phase wires, these are A, B, C, and this kind of interrupted wire for such lines influence on line resistance from the protected wire is zero because current can flow along it. Life changed. And what changed?
The insulation material.
No. OPGV answers.
OPGV.
Yeah. Keyword is OPGV. Optical grounding wire. What happened? Digital infrastructure. We need data transfer. For data transfer purpose, lines are needed. You need somehow to transfer this data. So what started power company? They started to use hollow protective.
Why transmission line using optical wire? There is any data is transferring between user and power plant?
First, own data flows. Dispatch operation, measurements, blah, office work, video broadcasting, and so on. But they lease this channel to IT components, to communication.
Okay.
It's what you can lease. And,
in European system, they are using transmission line also, optical data transmission.
More in our most lines are with up inside this OPGV. Second. I'll be back in a second. Here it is. OPGV. Outer layer, hard aluminum. There should be steel reinforcement. Inner layer aluminum, and inside a Teflon pipe should be, and they are optical. There should be fiber optics inside. Oh, it's hard, real stiff. Some of them are hard aluminum, some are, there should be a steel reinforcement. Can be used to teach some good method. So, this data transfer cables cannot be interrupted. And we return it to uninterrupted company pace for the circulating current losses. And current can flow. There is an alternative to use one way is to attach a cable to tower but below lines. Quite also expensive, and there is one moment. It's not cheap because it should be fully insulated Kevlar self-carrying cable for data, but this is not all. Everything fine until someone burns an old grass below line or some bushes. During this fire, low cable attached to towers, but at a lower level, usually melts.
Yeah.
The OPGV is protected.
Yes, in the C communication system also they are using same cable.
Oh.
But this is fully insulated.
Yeah, but this also has a water protecting shell.
No, here also using Sweden to communicate in RPR, right? The cable, underground cable.
Underwater.
Yes.
Underwater. But yes, it's a reinforced cable. So what's the point of interest? Point of interest, what? We have elongated conducted element over phase wires. That means what can we do? We can consider something like this. So we have A, B, C phase and one more element, ground. Wait 1 second. I'm drawing not in the base plate. This should be. We need to consider something like this. Here, the current will be 3 divided by 3, and here will be 3 poles. But it's a 0 sequence current. Okay, I will use Z, no Latvian ZEM. It's a ground current. What's the schematic I drawn? Actually, we can ignore direct and negatives. We can ignore this protective cable influence in case of direct and negative sequence, if we are performing so precise modeling, what we need to do it in phase coordinates, okay, it's possible, but in 99.99 cases, influence for direct and negative sequence can be ignored. It's only accountable when we speak on very, very high precision. For most case, we only
ABC is a vertical line, right?
any.
Any.
I just took in the way just to
Take the video.
illustrate anyone. Don't worry, I will show. It's for anyone. The problem reduces to zero sequence. We need to understand how protective cable influences zero sequence resistance. So I assume a modeling modeling schematics when we have three-phase wire, power from single current source, and our protective triple in zero sequence. We need to understand the influence in zero sequence. Would be nice to measure here delta zero to understand.
Yes.
We need actually we need a voltage drop. Connect here. We need a voltage drop to this will give us a unit resistance. We need a zero sequence resistance for the unit of such line length. So what will be our schematics? Ground here, active resistance of protecting wire, its self-inductance. This one is self. And 1, 2, 3, ground. Three, F, Y, H, Y. This is self for phase R at A. H, Y. Self for Y and B. Okay, I have three self. Next one. MAB. And this is MBC. MAC. And 1, 2, 3. between A and Y. And yeah. Here it is. Here is your model. Self resistance and the inductance of the free phase wires plus protective. Free mutual inductance between phase and free more magnetic coupling between phase and protective wire. Current here, zero sequence current equal by you divide by 3. Triple zero sequence current of protective wire and somewhere in ground flows triple ground current of zero sequence. Important moment. These three yellow are corresponding to A to wire, B to wire, and C to wire mutual resistance. Current directions in phase what's the direction between current in phase and in protective wire? Are they flowing in same direction or in opposite? You have current in wire, in phase wire, and current in protective wire. Are they flowing in same direction or in opposite? Opposite. This means what this yellow mutual resistance will increase or decrease zero sequence resistance?
Zero sequence.
Zero sequence. Will they increase or decrease?
I think it's a decrease.
Yeah, it's correct. They are decreasing. It's a first interesting moment. Protective wire decreases zero sequence resistance of line and increases fault current. Actually, this part is not a problem. This part is not a problem. We knew how to find a resistance of wire over ground, over conducting ground. One trick, one important moment. We are dealing with the zero sequence. And in our protective cable flows not a zero sequence current, but triple zero sequence current. 1, 2, 3 zero sequence currents, but this one is in neutral. It has a triple zero sequence current in it. This means what we need for this element, when we are looking for zero sequence, we need to put a triple resistance. We should use a triple. So if we need a zero sequence here, we should, meaning 3 times. If time because it's not a phase wire, but
Interact with ABC.
current, triple. So our equation for Latvian truss, each for protective wire, will be triple resistance of I ohmic plus 494 multiplied by 10 plus it's a ground component plus 0.14469 decimal logarithm of equivalent current depth in ground. Here, precise 149 meters, okay, it's average for Latvian ground, or 1 kilometer, divided by equivalent geometric radius of our protective cable. Now we need what? Model. Let's say A phase, B, C, protected. D, A, and distance between wire and protected. For such distance, for such placement, we will see, what can we see? We can write between A and K. It should be, as we did it for, as we did it before, 14469 logarithm equivalent depth A the same will be blah 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 the same B protective ground and metal resistance C the same, but it's simple. Now for 0 seconds, since I have equal current in all phase, I can write what? Zero seconds. One cable will be metal A plus B plus C cable. It's because I'm calculating 0 seconds. This will give me something like 0.1482 plus should be 0.4. Anyway, it's all imaginary. The 3.7, that's logarithm. No, it should be. U, D, A, D, B, D, C, cross. Okay. Now what we need, let this be a phase, фаза, like a phase to trough. Let it be. What will be my equivalent schematics if I knew this? Zero sequence resistance of my wire. Next, triple phase. Null secī. Zero sequence resistance of one phase. That metal phase to wire. This one. And two more same networks. All to ground, and I need this voltage drop. I need this voltage drop. So, per phase unit, voltage drop of zero sequence will be 1/3 of the current source. Phase zero sequence, self, minus zero sequence current in the protective wire, metal is to Y. Delta U, voltage drop in the protective wire, is free zero sequence of current of wire, it's zero sequence resistance, minus triple induced What's it equal? What's on the ends of protected wire? Grounded. Grounded at both sides. That means what this term is 0. It's equal to 0. This gives me a system of equation, isn't it? System of equation because I need this, eliminate this term. And now get zero sequence voltage drop will be 1/3 of the current source, self zero sequence resistance of the wire minus the ripple metal resistance phase to wire divided by triple zero sequence self-resistance of protective wire. This also should be multiplied by current, and all this multiplies by metal resistance phase also. So, for one stage of transposition, for one stage between transposition barrels, this will be current source divided by 3, zero sequence of the phase self resistance minus square of the metal resistance phase to wire divided by its self resistance. Since we assume line full transposed, it's one moment, it's a Demon underload stall. These nice formulas assume what we have full transposition cycle in line. It means what they are not 100% precise. They are usable, but if you need really precise data, these nice formulas from the nice books, they go from book to book in one or another way without any explanation. They just give you the end result. And therefore fully transposed symmetrical line. Fully transposed symmetrical line has at last 3 or integer multiplied by 3 barrel to barrel stage twist. Meaning, for my nice formula, this summary will be triple phase and this will be phase minus metal phase to protected wire square divided by ohm or self zero sequence resistance of the protected wire. I hope this formula is correct. Because it will be over resistance of the face wire plus 0.1482 plus 0.43407 decimal logarithm of cube divided by equivalent radius by distance square minus 0.1482 plus dot 0.43407 decimal logarithm of equivalent this divided A B this should be square divided by triple self-resistance of protective wire plus 4.94 multiplied by 10 plus yod 0.1469 logarithm GM equivalent geometric radius of the protective wire. Here it is. It's for 50 Hertz, zero sequence resistance in ohms per 1 kilometer. Do I take a time? Who's phone can you what? Kučkovski mums visi attiecībās nebūs. Inga tagad neimas. Mēs tieši vakar runājam. Jā, un Inga grib sarunāt savu draugu Kovaļevu. Jā, tie vakar tika mēs apspriedam. Kā būs. Nu, ja nesarunās Kovaļenka, būs pozīcija. Jā, vārdik,
I try to give it them.
Palaidi, kas atbildīja.
But I'm not got the exact answer.
Okay.
Yeah,
Will you survive parallel lines? What can we do if we have two parallel lines in common? Like you show on, let's for example, what can we take as example? Two lines share, for example, A1, B1, B1, C1, and on the other side we have A2, B2, C2, and protective cable on the top. We have two lines sharing same tower system. Can it be? Possible. 1 second. Where I two line. One, two. Nice? Nice. And now not so easy. A1, let's say B1, C1. I don't know. In red. A2, B2, C2. Distance D, A1, B1. This will be A1, C1. This distance D, A1, A2. Distance A1, B2, and distance A1, C2. Idea is clear. How distance are marked? Why I'm doing this? In general, if we are ready to live, we agree to live with the error, we can assume full transposition cycle for both lines. This means for direct and negative sequence, mutual influence is what? Neglectable. In case of full transposition this cycle, we only need to account mutual effects for zero sequence. In case we need high precision, prepare to open a Hell gate. You will deal with schematics. It takes a free in AutoCAD drawing in small designations. If you want, I can show the schematics. I knew guy who calculated it.
Professor, how I can calculate three-phase system in the distribution? Because the distribution A, B, C is a parallel.
No problem.
No problem.
Absolutely no problem. Can you measure distance?
Yes.
Of course. See, in the middle voltage system, you most possibly will have isolated natural. This means it depends on precision. For ordinary fault current, F zero sequence effects is neglectable because you have an isolated natural. Direct negative sequence is neglectable because you don't need so high precision. If you are looking for high precision calculus, really high precision, for example, you're calculating losses and you need real precision within 1000, that means what you in trouble, because you will need to split line into split all into stage and calculate each stage in phase coordinates using this first formulas I started with. Not the summary for whole line, but formulas I started with. You need to perform a modeling in phase coordinates. But it's only in case you need a real high precision. A precision something 1 in 1000 or better. It's a very rare case. Honestly, I don't know who may need to do this for middle voltage network. This is done for high and super high voltage network and only for one purpose, for fault location. Where achievable precision is something like 300 of line length, or 300% of line length. It's what achievable with a very good current transformers. This one, yeah, transmission. The first one is something like 500 kilovolts or above. 200 you need a zero sequence. 110 for the ABC, yes, and 2 model is bit more complicated. It's actually it's the same, but you put 2 protective cables and assume neutral 1 and 1 to 3.
Then here is different distance only.
Anyway, take distance from ABC to
in this also.
And this,
no problem.
Ignore it, simple, because this will be an isolated network, isolated neutral network, and this ground current
so
means
it's not a
nothing.
problem. Only transmission line is a problem.
For transmit, actually, we start to processing from 100 kilovolts.
In my country, using sometimes in the village, rural areas, distribution line post is a transmission line. Sometimes.
It's possible if companies can agree. See, it's first thing you start with, who's the owner of towers.
Okay.
If the same company, no problem. If they are different, have starts. It's normal. Real, it's normal to use this to share tower system. It's normal in one tiny moment. And this tiny moment, you know where the tiny moment is? Tower to tower distance. If you mechanical strength of the wires used for, let's say, 220 kilovolts is much higher when needed for 10 kilovolts or 11. This means what you will need to put middle voltage force in the middle. It's for 35 kilovolts. It's okay, but for the higher voltage, the highest tower to tower distance. It's good, but small problem. So I saw only some tower share it and it all. Using on all distance, I don't know, maybe some old design line with wooden poles. But actually,
America also using wooden poles.
I saw them, yeah. Here also we had small segment near kegels of wooden poles. Again, today, not paste. If you have a very cheap wood, but for wooden pole, you should understand 20 each distance of max 25 years, wooden poles need to be replaced. Steel towers, especially zinc coated, can serve you 100 years. It's not profitable. And one more moment. In inhabited areas, you have a minimum distance from ground. This means that your wooden pole will be A-shaped with two wood segments at last. It's a complicated design. A wood of such size is problem. At present moment, getting so-called mast timber, what was used for ship mast, try to buy. Really, it's a high quality timber. Try to get it. You cannot use glue. At our moment, it's not paste. Okay, what I want to draw. Yeah, schematic used to calculate influence or coupling effects from the second line to my first one. It's for direct sequence. Wow. Okay. This is funny. I forgot how far I this is L wire, this is L wire for A phase, and it's for first line. This will be a square 1 L wire B for the first line, and one more L wire C for the first line, and this one is A for the first line. This will be grounded. Next one. It can be represented as ZAB for the first line. Next one, Zm bc for the first line, MAC for the first line, actually I should use a big AB, AC, B1, C1. Block, block, block. Here will be for the second line its current source, its Y, and IRA for the second line, here will be neutral A2, B2, and important thing, this one, it's neutral A1, A2. It will be a company, I don't have space, with neutral A1, B2, and third neutral A1, C2. And return. I omitted a part for second line. It's the same as for the first one. This part is difference. It's a metal inductance between
A and A. Okay. A1 and A2.
Yeah, A1. The same will be for the B and C phase. This voltage drop will represent a visible direct sequence resistance for the first line A phase. This voltage drop will be multiplied by A phase itself of the first line plus first current source multiplied by S squared neutral A1 B1 plus A Z neutral A1 C1, it's a self voltage drop plus neutral component A1 A2 plus second, sorry, this is A squared Z neutral A1 B2 plus A Z neutral A1 C2. Yeah, here it is. Nice. self of that first line of A phase. Its a self part will be via resistance of the A phase 1 plus 494 multiplied plus dot 144 69 logarithm of the Z equivalent current depth RG A phase first line. Geometric equivalent of the A phase Y for the first line. Nice. This will be in ohms per 1 kilometer. A1, B1 will be 494 multiplied by 10 plus dot 0.14469 logarithm the Z divided by B A1 B1. AC for the C1 for the first line will be the same, but under logarithm we will have A1 C1. So, if I combine all these three formulas in one, I will get so-called self-voltage drop. Voltage drop in absence of the second line. Self-voltage drop 1 equals to 1 multiplied Ly for the A plus 494 multiplied by 10 plus dot 0.14469 decimal logarithm of the Z and equivalent radius for A phase plus A squared multiplied by 494 multiplied 10 plus dot A squared 0.14469 decimal logarithm of the Z divided by A1 B1 plus, I need more space, I need space for mutual with phase C. This will be, I will continue here, plus A 494 multiplied by 10 A 0.14469 decimal logarithm of the Z divided by distance between A and B on the first line. It's a self without I can simplify. Only one page of handwritten text, and it will be equal to 1 L1, and here A phase active resistance minus 1,253 logarithm of distance A1 C1 divided by distance A1 B1 plus 0.14469 logarithm of A1 B1 distance A1 C1 divided by equivalent radius of A phase of the first line. Oh, nice formula, isn't it? Take a look on this formula. You see difference? It's for untransposed line. This one is for one point. I want to use Latvian porcelain. For the one stage between, one distance between barrel to barrel, between transposition barrel. This one is for non-transposed line. Now I need a second. This one is self, without influence of the second line. Now influence of the second line. I was very enthusiastic conducting this. Influence of the second line will be second current multiplied by this length. Actually, it's the same. Okay. Key moment. This part, this length is not the own length of the second line, but the length. This is L1, and this distance is L2. Not if they are not if they are not parallel on the whole distance, it can be a mistake. This one is a distance where they share this length. So it will be
here delta U is not 0.
Not 0. No. It's an influence part from the second line. It will be 0 if it will be no current in the second line. No, it's not 0. So here we will have something like 0.14469 multiplied by decimal logarithm of equivalent depth A distance A1, A2 minus 1/2 of the decimal logarithm square divided by A1, B2, A1, C2 and plus your square root by half decimal logarithm of distance A1, C2, A1, B2. I hope this is correct. When I conducted this formula some 10 years ago, should be correct. I've checked final results. Looked okay. So it will be A2 here minus 0.1253 logarithm distance A1 C2 divided by distance A1 B2 plus dot 14469 logarithm of A1 B2 distance A1 C2 divided by distance A1 A2. I hope it's correct. The resulting voltage drop giving us direct sequence resistance for the system of the parallel line. It's delta U self plus delta U from the second line. This can be written as first source, first line length, direct sequence self-resistance of the first line, plus my current in the second line multiplied L2, it's a length of common multiplied by, it can be represented as a mutual Z12 in use it. One. Here, self-resistance for the A phase, for the direct sequence, for the first line, it's via self-active resistance minus 0.1253 decimal logarithm. Distance A1 C1 divided by distance A1 A1 B1 plus 0.14469 logarithm of square root distance A1 B1 distance A1 C1 divided by equivalent geometric radius of the A face, it will be in ohms per kilometer of length. It's a self. Final end with self resistance. This one is for untransposed lines. This is more precise. And mutual direct sequence, mutual resistance between line 1 and 2 will be minus 0.1253 logarithm distance A1 C2 distance A1 B2 plus 0.14469 decimal logarithm of square distance A1 B2 distance A1 C2 divided by distance between A1 and A2. Again, ohm per kilometer. This one, this tag, usually is less than 1/3 of the direct sequence self-resistance, but it's not zero. And it's a source of quite mystical thing. Current in the disconnected line. You can have a disconnected line, but you see an induced current in it from the neighboring line or lines. If system would be fully symmetric or full transposed, everything fine, induced current will be zero. But since you have not ideal system but real, which is known as symmetric, you get this term will be not zero, and you will get induced current in the disconnected line from the load regime of the neighboring line. Okay, I understand. My time is